Assalamu alaikum wa rahmatullahi wa barakatuh, guys. I hope you're all well. All right, guys, we're gonna start. Okay, so we got different students joining us today. So obviously it's a maths class. So guys, before we start, this session is a last minute revision for all the predicted topics that's gonna come up for the paper one for maths paper one. Okay, so inshallah, just to clarify some of the rules, is from amongst the rules. No, this one is going to be focusing on higher and foundation because as we know, higher and foundation does share a few topics. Okay, so okay, so the plan is today is that it's a 2 hour long session. We're gonna do 55 minutes, and then we're gonna have 10-minute break, and then we're gonna come back and do another 55 minutes. Okay, so it's not gonna be a straight 2 hour. Okay, that's gonna be too much, right? I'm just adding all the students in now. Let me just add up for fine. Okay, so we're gonna quickly go through this. All right, all right. So this is the topics from what I understand are going to hopefully come up from me checking other also other mathematic experts that have also predicted what topic is going to come up. Okay, right. So first and foremost, we're gonna go with something very simple. Okay, negative numbers. We're gonna talk about BIDMAS. Let's get straight into it. Okay, so over here we're gonna first. Sorry, let me just get my pen up. So a lot of people would can get these answers incorrect. Okay, so what I'm going to do is I'm just gonna okay, there's more people coming in. So when we talk about BIDMAS, we're gonna work through the brackets, the indices, the divisions, the multiplication, addition, and subtractions. Okay, so first and foremost, we talk about the division. At this point, you will have 5. At this point, at this then you're gonna do the multiplication. You go -6 plus 5. You're gonna have -1 at this point. Okay. Second thing is you have the from the brackets, you have the indices that's going to turn into a 4. Then you have the division, which is going to turn that into a 6. So, and then from here you go -12. Okay, you add these two up, that's going to give us 10. -12 is going to give me -2. Okay, last one, we're going to look over here. We're going to first talk about the indices. Okay, so at this point we have the indices first. So I'm gonna go quite fast through these topics, okay? Just to make sure we understand them, okay? So we do -5 squared, which is going to give us 25 plus, okay? Then after that we can divide these two, division, okay? We're going to have 3 at this point, okay? And then we have the -5 times 5, that's -25. These two cancel each other out. We have number 3, okay? All right, guys. So this is quite straightforward. Negative numbers. If you don't know how to do negative numbers, you're gonna struggle with the whole exam, okay? And if you don't know how to multiply decimals, that's another problem. You need to know how to multiply decimals. You need to know how to multiply with negative when it comes to BIDMAS, okay? Simplifying and whatever you may have, okay? Right, okay. Sorry, there's loads of more people coming in, okay? So obviously we have some students that are from school, there's some students that are not from school. So there's loads of people just joining in, okay? So just make sure we don't get disturbed. Right, okay, let's move on. Is everyone happy about that? Let's move on to the next topic. So we talk about a fraction of an amount. Simple, very easy, okay? We should know this. So we have these questions over here. I will actually ask you guys to quickly answer these questions. I don't want to do it for you. I want you guys to answer them yourself, okay? Have a go, answer them yourself, and then we're going to move on. Write the answer in the chat for me, please, yeah? Do not use a calculator, guys. Do not use a calculator. Okay, excellent. So we just got the answer over here. So the word off in maths means times, okay? So we have 3, when we have 3 over 5 off 30, that means we're going to multiply by 30, okay? So we can either divide it by 5 and then times it by 3. I think that's the better option, okay? So divided by 5 is 6. 3 times 6 is going to give us 18. Next question is over here. We have 2 over 7 off 14. You times it by that. So we divide it by 7. which gives us 2, okay, times by 2, it's going to give us 4. Next one over here, we have 3 over 8 times 40. We're going to divide it by 8, that gives us 5, times 3, that's going to give us 15. Okay, so we should be very quick and straightforward with these questions, okay? Are there any questions about this? If you don't understand this, let me know, I can explain this further. The word of in maths means multiplication, okay? Fraction of amounts, okay? This is more to do with foundation topics as well, including the first topic that we did, negative numbers, and it's to do with higher topics, okay? So it's a mixture of both. Right, let's move on, okay? Okay, so fraction, to do multiplying fractions, subtracting, dividing, mixed fractions, okay? Again, when we multiply fractions, okay, we have to know the difference, okay? So example now, this can be turned into a mixed number, okay? So when we have the names, we should know what the names are. Proper fraction, we got the improper fraction, and we got the mixed number, okay? So we should know the different names of things, okay? You can see the difference between proper fraction and improper fraction is the value on top. The numerator is more. Okay. Coming to the multiplying over here, when we multiply fractions, we multiply top numbers is 6, multiply bottom numbers is going to be 12. We can simplify this to 1 over 2. Okay. Next thing, when it comes to dividing, we can swap them over. So 2 over 3 times 4 over 3. We multiply them, we get 8 over 9, and we leave it at that. Okay. Right. Next one over here, subtracting fractions, okay? We need to make the base the same, so we can do 20 minus 20. We multiply this by 5. We multiply this by 4. Okay, whatever we do to the bottom, we do to the top the same, times by 5. We're going to get 15 to multiply by the top, same bottom, times 4. That's going to give us 8. We subtract them 2. That's going to give us 7 over 20, okay? All right. So next one over here, mixed fractions. Okay, we can turn them into a improper fraction, then sort of do it, or we can either do it straight away. I like to turn the improper fraction, so we do it 1 times 5 plus 2. So 5 plus 2 is 7, 7 over 5. And then we can do the same thing over here, 2 times 2 plus 1, and that's going to give us 5 over 2. Okay, again, we need to make the denominator the same. So it's going to be 10 plus 10. Okay, so 5 plus, to get from 5 to 10, we multiply by 2. To get from 2 to 10, we multiply by 5. Okay, whatever we do to the bottom, we do to the top as well. We multiply by 2, we get 14. We multiply the top one by 5, we get 25. Okay, once we've done that, we just add them. That's going to be 39 over 10. All right, so which we can turn into we can turn to a mixed number again. So it goes, we can say it goes 3 times, 10 goes 3 times into 39, 3 and 9/10. Okay, we can turn it into this. All right, next question. Let's move on, guys. Okay, is everyone happy about this? Okay, I hope everyone gets this. Okay, right, good. Let's move on. Okay. Okay, when it comes to recurring decimals, okay, this is very important. This is a non-calculator topic, so you won't have any calculator. So first and foremost, if we have this, we have to convert this into a fraction. What we need to do first and foremost is that we need to first make x equal to 0.5 recurring. It's like a simultaneous equation, okay? So the second thing we do is we have to isolate the one decimal, the recurring decimal, okay? So we multiply by 10 because it's repeating every one decimal, okay? So we multiply by 10, we get 5.5 recurring. It doesn't affect the reoccurring because reoccurring is infinity. It goes 0.55555 for forever, okay? So what we do is we do like a simultaneous equation. We subtract the two equations and we're gonna work out the difference. So 10x take away x is 9x, 5.5x take away 0.5 recurring is going to give us the following, okay? So when you subtract these two, we're going to get 5. So 9x equals to 5, okay? This is what we have. Now, once we have that, we can then make x the subject, okay, to turn it into a fraction. So all we're gonna do is we're gonna do 5 over 9, so x is equal to 5 over 9, okay? That's an easy one. That's a very easy question. Okay, next one. So we're going to convert 0.12 reoccurring. That's two decimals that are reoccurring. Okay, same thing. We make x equal to 0.12 reoccurring. We multiply by 100 because it's two decimals that's being repeated. Okay, so the recurring part is isolated. Okay, that's the main part. The recurring part is isolated. We subtract the two equations and we're going to get 99x over 12. Okay, 99x equals 12, sorry. And so we make x a subject, and so we're going to get x equals to 12 over 99, which is same as 4 over 33. You don't have to simplify in the exam. Leave it as it is unless they ask you to. Okay, don't waste your time simplifying things. Okay. Next question, we have three decimals that's recurring. Same thing. Okay, as you can see, there's a pattern here. Whatever number is over 99. Same thing with this. Okay, we do 99. We do the number over 99. So we're going to get 427 over 99. But it's not as easy as that. A lot of people think it's just that number over 99, depending on whatever number that is. It's not like that. If we were to move on to the next type of example, we will see that when it comes to questions like these, okay, where we have 1.7 reoccurring, we want to make x, we want to isolate the decimal now, okay? So what we're going to do is we're going to multiply by 10 again, and we're going to get 17.7 recurring. This time, you're not going to only get 17 over 99. No, you're going to subtract the two and you're going to get different answers, slightly different. Okay, so you're going to get 16 at this point. So you're going to 9x equal to 16. You divide both sides by 9 and you're going to get 16 over 9. Okay, so it's a bit different to the previous example. Now, the next question over here, we're going to have another example. So we got 2.48 recurring as to a fraction. So we let x equal to 2.48 recurring. Okay, we make because two decimals, we want to isolate two decimals, so we multiply by 100 both sides. Okay, so we're going to get 248.48 reoccurring, and then we're going to subtract the two equations, get 99x. We're going to subtract the two over here, and we're going to find we're going to get 4246. Okay, when we subtract the two equations, and so we divide both sides by 99, and we should get x equals to 248 over 99. Okay, this is called recurring decimal to fractions. Okay, all right, let's look at the hardest question, where the hardest type of recurring decimal question we can get. Okay, does the fraction to recurring come up? Yes. No, fraction to recurring, it can come up, but it shouldn't come up. No, because yeah, that usually doesn't come up. No. Okay, it's usually recurring decimal turning into a fraction, not the opposite. Okay, right. This is the hardest as you can get. Okay, so for example now, and this one, a question like this as well. So we have to again isolate the recurring part. So we can see that there's decimals within both of our questions that are not reoccurring. Okay, so what we're going to do is we're going to isolate that 0.02. Okay, so we have to multiply by 10. Okay, once we do that, we're going to get 7.22. Okay, we do the same thing, subtract the two equations like simultaneous equations using elimination method. We eliminate the recurring part and we're going to get a different number. Okay, so we're going to get, at this point, we're going to get 6.5. We know 6.5 isn't we can't turn that into a fraction unless we multiply both sides by 10. So what we can really do is 6.5 over 9, we multiply both sides by 10, and we should get 65 over 90. This is as hard as it gets. It won't get any more difficult than this. Okay, and then afterwards we can simplify further. Do not, guys, my advice is do not waste time simplifying questions. Okay, if you're not asked to simplify questions. Next question, exercise number 6, convert this into fraction. We have x equal to 0.481 recurring. Okay, so what we're going to do is we're going to do 100x equals 48.181 recurring. We want to isolate that because there's two decimals. That's the reason we multiply by 100, because we want to isolate that 0.81. Okay, so we want to align them. That's how we know we've done it right. Okay, then when we subtract the two, okay, equations. Yes, I'm recording this. I'm going to upload it straight away once I've recorded. Okay, so I'm trying to go as quick as possible through it. Okay, so we're gonna have a break at 8:55 or something like this. Yeah, just to make sure that you guys can have a breather as well. Okay, so Once that's done, okay, we're going to then subtract the 2. We're going to get 47.7. Okay, we can multiply both sides by 10 to get it into a whole number. We make the x the subject, and so we can then simplify further. Okay, so you're not expected to simplify this, but this is the hardest as it gets, as I said. Okay, so this is recurring decimals as a topic. So we've gone through 3 topics or 4 topics so far. All right, let's move on to the next one. Product of prime factors, okay? So if we have starting number 48, we want to break it down to its product of prime factors. This is to do with foundation topics and higher topic. We can just have 2 numbers. Usually we can have divided by 2 into prime factors, and that automatically would give us the next. Sorry, there's more people coming in. All right, so we can just break it up into its prime factors and break it up further. So with the orange numbers are the prime factors, and so we need to break each number. A prime factor is a number that can only be divided by itself or 1, okay? And these are the number can only be divided by itself or 1 in order for you to achieve an integer, okay? And this is what we have. So if you want to write it in terms of prime factors, it's going to be the following, okay? It's going to be 2 to the power of 4, because we've got 4 2's. 1, 2, 3, 4 times should be in times of it, times 3 equals to that. Okay, so that's how we write these questions. Okay, so this is product of prime factors. Make sure you write this as an answer. Okay, that's the product of prime factors. Next question, we're going to talk about laws of indices. Okay, now this is going to get the way I've sort of structured this these questions is from the easiest to the hardest. Okay, so over here, all we're going to do is when we have the two we're gonna multiply that whenever we multiply 2 powers, we're gonna be adding the indices. Okay, so example, now in this case we're gonna have x 5 to the power of 5 plus 4. That's going to give us x to the power of 9. Next question. So when we're multiplying powers, we're adding the indices. Okay, when we're dividing the powers, we're going to be subtracting the indices. Okay, so in this case we're going to do x to the power of 10 minus 3 instead of, because it's division. And that's going to give us x to the power of 7. Next question, when we have brackets, we're going to multiply, okay? So we're going to have x to the power of 3 times 4. So we multiply the 2. 3 times 4 is going to give me x to the power of, 12, okay? That's going to get x to the power of 12. Next question. Now, this is called fractional indices. Okay, this is where it gets slightly more difficult, okay? So the fraction, the index, the denominator, okay, for the fractional indice, the denominator is a root. Okay, so this number over here is a root. So what we can say is this is equivalent to a square root of 9, and all of that is going to be cubed. So square root, we can write a 2 there as well, okay? So square root of 9 is going to give us 3, and 3 to the power of 3 is going to be 3 times 3 times 3, which is going to give us 27. Okay, simple as that. Okay, so remember the denominator of the fractional indice is a root. Okay, don't get that mixed up. Now this is a negative fractional indice. Okay, and when it comes to negative fractional indices, that negative number is a reciprocal. Okay, so we have 1 over 27 over 8 brackets 2 over 3. Okay, so what happens when you have a reciprocal? The whole thing flips over. Okay, we can either do this first. Okay, so let's just work this out. So we got 1 over. So remember, the denominator of the fractional indice is a root. So that's a 3 root 27, or cube root 27, or cube root 8. Okay, so we're going to do 3 root 27, and we're going to do 3 root 8. Okay, all of that is going to be squared, and so we got 1 over 3 over 2, all of that is squared, and so when we square it, we're going to get 1 over 9 over 4. We flip it over because we got a reciprocal of a fraction. We flip it over and we're going to get 4 over 9. Okay, that's our answer. Okay, let me write this properly. 4 over 9. Okay, that's what it is. Next question. Okay, so over here we have a when it comes, we got another fractional indice. In this situation over here, we're going to apply the power of half to all of these terms, okay, both of these terms. So we're going to do 9 to the power of half times x to the power of 6 times a half. Okay, can you see what I'm doing over here? So, okay, that's fine. So what we're going to do is we're going to do so power. So remember the denominator of fractional indices is a root. So root 9 is going to give us 3 times is going to x to the power of 6 divided by 2 is going to give us 3. So that's going to be 3x cubed. Okay, that's the answer for that. Okay, so that's the first one. All right, that's a different type of question. Now this is called algebraic indices. Okay, so we have to work out what this is. Okay, so the first thing, what we want to do is we want to apply something that is going to multiply 3/4 times something that gives us 1, and that which gives us 1 is actually 4/3. Okay, so because 12 divided by 12 is going to give us 1. So we apply 27 to the power of 4/3. So what we're going to do is we're going to cube root the 27, okay, and then we're going to do to the power of 4, and that's going to give us 3. So because 3 times 3 times 3 is going to give us 27, and we're going to do 3 to the power of 4 is going to be 3 times 3 times 3 is going to give us 27 times 3 is going to give us 64. 1 second. 27 times 3. Let's quickly do this. 1 second. So we're going to get 21, 6, 8, 81. Yeah, sorry, it's 81. Okay. All right. So next question over here. When we have this question over here, we're going to get a different answer. Okay. So this is solving this is solving a fractional indice. So we're gonna first apply. We first want to see what number multiplies with x to the power of -2/3 to give us 1. So -2/3 times something gives us 1. So that number is going to be -3/2. Okay, so we have to apply this to the opposite effect to the actual answer to get x. Okay, right. Okay, someone set the captions to Arabic language. Okay, interesting. Okay, all right. So what we're gonna do is we're gonna first enter the fraction. So 2 times 9 is 18 plus 7. Okay, that's gonna give us 25/9. Okay, let's do that again. 18 plus 7 is 25/9. Okay, so now once we have this, we can actually apply this one over here. So we're gonna apply -3/2. Okay. And at this point, what we have is we have the negative, which is a reciprocal. Okay. So that's going to give us 1/25/9, and all of that is going to be 3/2. Okay. So what we have next is we're going to remember the root of a fractional indice is a root. Okay. So what we have over here is 1/√25 over square root of 9. Okay, that's going to give me 3. Okay, so now after we've done that, we're then going to basically do 1/5/3, and then we're going to cube it. Okay, we're going to cube it. 5 times 5 times 5 is 125. So it's 125. Okay, and 3 times 3 times 3 is 27. Okay, and then because we got a reciprocal, it's going to flip over. It's going to be 27/125. Okay, that's the final answer for that one. Okay, all right, next question over here. This is called also algebraic indice. Okay, so we have to find out the value of x again, but this time it's a power. So this is the hardest it gets. This is level 9, and to the point that some of this also goes into further maths. Okay, how do you know to flip it at the end? Okay, because it's a fraction, it's a reciprocal. Guys, if you have any questions, do ask her. Because it's a reciprocal, the reciprocal flips the fraction. So example now, if you have 1/a/b, the reciprocal flips it over. It multiples, so the b multiplies to the a 1, and it becomes b/a. That's what happens. Okay, right. next question. Okay, so what we have over here is we have to turn the base to be the same. Okay, so what base do they both share? Okay, they both share a 2, so we can turn 4 into 2 to the power of 2 brackets x, and then we have equals to 2 to the power of 10. Okay, so at this point, what we're going to do is once we have the same base, we can then leave it at 2 to the power of 2x equals to 2 to the power of 10. And we know what number multiplies with 2 to give us 10. So we can just write 2x equals to 10. And we know that divided by 2 divided by 2, x equals to 5. Okay, we got that. Okay, that's your answer for x. All right, next question over here. Okay, this question at the over here. So now, if I want to make this into a so first and foremost, I have to make the base to be the same. Okay, so I'm going to do 2 to the power of x equals to, I can turn this into the power of 2 as well. Okay, so if I do 2 to the power of 3 brackets 3, because 2 to the power of 3 is 8, yeah, and I can do divided by, at this point we have 2 to the power of half. Okay, 2 to the power of half, because we know square root is a half. Okay, so what we have at this point is we need to turn the bases to be the same. Okay, once we have done that, we can just simply put them together. Okay, so 2 to the power of x equals to 2 to the power of 9. Okay, take divided by 2 to the power of half. Okay, so at this point, what we're going to do is we can just subtract these two. We know that these two are going to give us the following. Okay, so it's going to give us x. So we're going to x equals to 9 minus half, and that's going to give x equals to 8.5. All right, guys, this is as hard as indices get. It is quite difficult if you don't know this. What I would say is you're safe if you're up to here. Up to here, you're safe. Foundation level would probably be up to here. Okay. This is goes over a lot of people's heads. Okay. So don't worry if it does. All right. Are there any questions? Does anyone need to copy this down? Okay. If anyone does need to copy this down, let me know. If it's difficult, then do let me know. Okay. What's the time right now? Okay, so we're nearly gone half an hour, so we're in a good pace at the moment. Okay, there's quite a lot to cover. Um, okay, so let me allow you guys. Okay, so we're gonna go to the next topic, okay? Surds. Okay. What I want you to do is I'm going to give you 5 minutes. I'm gonna give you 10 minutes to try out these questions, okay? Because I feel like I'm doing all the work. You guys try this, okay? You guys try this, and then you guys tell me how you're finding it. All right, so surds, I'm going to give you 10 minutes to do as many questions as possible. Write the answers in the chat for me, please. Let's have a go. Okay, 10 minutes. Sirs, yeah, it does come up in foundation paper to some extent, yeah. So guys, not all about getting it right. It's also to get it right in like to do it in correct time within time. Yeah. All right, guys, I might start a bit earlier than expected. So I got some answers from people. If you're not doing the work, then you should, guys, really, because you got exam tomorrow. Okay. Okay. Well done, Jacob. Okay. Let's sort of start going through them. Okay. So this is everything, all the from the most difficult questions of surds to the easiest. Okay. Um, and we're gonna be trying to go through as much as possible. Okay. All right. Just looking through some of the questions. Okay. So over here. All right, at this point, okay, so what we're going to do is, so the last one is 7 plus 3 square root over 1. Okay, we'll go through, okay? So the first one, what we're going to do is, first we're going to multiply these two. We're going to get the square root of 6, okay? Same thing. So example now, if you treat them like a fraction, the front numbers of the roots multiply inside the roots multiply, okay? So we can actually say that when you have square root of A times square root of b, you can actually say that square root of A times B, okay? And again, same thing, if you do square root of A divided by square root of B, you can just say square root of A over B. It's true this way and it's true that way, okay? Same thing with the top one. That's the rules of surds, okay? So root, as we know, square roots or root numbers are surds. Surds are irrational numbers, okay? If I do square, irrational numbers are numbers that go on for infinity. They don't make sense, okay? Sorry, let me just cancel this timer. Okay, they don't make sense. So what happens is that so we can't multiply an integer or a rational number with an irrational number. They don't go together. Okay, so when we multiply these two, all we're going to do is we're going to do square root of 3 times 2. That's going to give me square root of 6. The next one over here, same thing. Just like we can turn this into this, we can turn that into that. So we can say this is equivalent to square root of 1 over square root of 9. And that can give us 1 over 3. Okay, simple as that. Okay, next question over here. Now, this is to do with simplification of surds. When we are simplifying the surd, the objective is to create the biggest integer possible. Okay, so simplification of surds is objective is to create biggest integer possible. Okay, now that might not make sense to you, okay? Because like example, now simplifying, for example, now an equation is to sometimes to condense or make something compact and smaller. But simplifying in regards to the surds is to actually make an integer, even though it may look more complicated. Yeah, I can give you maybe an example. Okay, so example now, the square root of 50. How do we simplify the square root of 50? Okay, we need to break it down into a square. The biggest square number of 50 can be broken down into. So I'll do the square root of 50 can be broken down to square root of 2 and square root of 25. Yeah, so I'm trying to create the biggest square number possible, okay? So over here, when I do square root of 25, that's going to give 5. So that is 5 square root 2. This looks more simplified than this. However, this is the correct answer. I have simplified square root of 50 to make it into 5 square root 2. Okay, that's the objective is to get the biggest integer possible. Okay, right. Okay, okay, so next question over here, for this one over here, okay? So we have 2 square root 50, okay? Again, we can break it down into 2 square root 25 square root 2, okay? And we're going to get 2, because between each of these terms is a multiplication. So 2 times square root of 25 is 5 square root 2, and that's going to give us 10 square root 2. So that's our answer over here. Okay, next question over here, same thing, okay? So what number can this, okay, so what we can do is, because we've got imaginary 1, we can treat them as a fraction. So 1 square root 18 times 4 square root 2. So we multiply the integers and we multiply the uh, irrational numbers, okay, or the surds. So we're going to get 4 square root 36. Now, square root of 36 gives us 6. So that gives us 4 times 6 is going to give us 24. That's our answer over here. Okay, next question over here. Now, when we add surds, we can only add surds just like fractions. We can only add them when they have the same surd or the same irrational number, okay? I cannot add surds, so I can't do this. If I have square root of 5 plus 2 square root of 4, I can't do this. I can't do this, okay? So what I can't do this, I can't do this. I can't do 4 square root of 9. It doesn't work that way, okay? You can't do that because I can only, you have to treat them like fractions. So example, now if I have 2 square root 5, I'm going to leave it as 2 square root 5 plus 1 square root 5. And in the fraction, I only add the numerators, okay? So I'm going to be adding 2 and 1, and I'm going to get 3 square root 5. And I can only add them because I got the same denominator in a fraction. But in this, I got the same root, you can say, or the same surd. The reason why I can add them. Okay, so that's the final answer. Okay, this question over here. Now, at this point, I can't add them because I don't have the same surd, okay? So I need to create the same surd. So square root of 8 can be broken down into square root of 4 and square root of 2. So now I got two similar bases or two similar surds. So what I'm going to do in this case over here, I'm going to simplify it into square root of 2 plus 2 square root of 2. There's an imaginary one over here. So 1 plus 2 is 3 square root 2, and that's the final answer. Yes. Okay. All right. No, that's not correct. Someone sent me a working out. Yes, you can do that method as well. Okay, you can do that as well. Yes, thank you. All right, so you can. Okay. All right. Next one over here. All right, let me just get rid of this. Sorry. Yeah, it's just glitching slightly. Okay, so let's have a go at this. We're expanding brackets when it comes to surds, okay? Okay, we're running low on time, so let me try to be quicker. Okay, so need to multiply the square root of 2 to square root of 2. That's going to give me square root of 4. I'm going to multiply square root of 2 to minus 1. It's going to give me minus square root of 2. I'm going to do 1 times square root of 2. It's going to give me a positive square root of 2. I'll do 1 times minus 1 is going to give me minus 1. Now, square root of 2 gives me 2. These two are opposites. They cancel each other out. So I'm left with 2 minus 1, and the answer is 1. Okay, understand how to expand brackets using surds. Okay, similar concepts, but it's just expanding brackets using surds. Surds only goes with surds. Rational numbers only go with rational numbers. Okay. Okay, next one over here. Now, rationalizing the denominator. What does rationalizing mean? Rationalizing mean make sense or make the denominator to become a rational number. A rational number is an integer. Make it into an integer. Okay, or a whole number, if you want to call it that way. If I want to do that, I need to multiply by itself. Okay, so square root of 10 times square root of 10. So 8. Whatever I do to the bottom, I need to do to the top. For example, now, if I want to change the bottom, I multiply by 2, and I multiply this by 2, so I get 2 over 4. 2 over 4 is equivalent to 1 over 2. Same thing over here. Whatever I multiply the bottom by, I need to multiply the top by as well, okay? So I multiply the top and bottom by that, so I'm going to get 8 square root 10. Square root 10 or square root 10 is going to give me 10, okay? Because that's going to give me square root 100, and when I do square root 100, that's going to give me 10, okay? And so I can simplify further, okay? I can divide the top number by 2, I can divide the bottom number by 2, and I'm going to get 4 square root 10 over 5, okay? Now, I can't divide the square root 10 by 5. I can't make it into a 2, because remember, irrational numbers and rational numbers don't go together. You have to understand this very important concept, okay? And these questions come into proving. They will give you a crazy surd number for you to prove to become something else. And if you don't know the rules of surds, you're going to get completely messed up, okay? Now, how do we rationalize a surd like this? We have to multiply the bottom number by a negative version of it, okay? So we multiply by square root of 3 minus 1. We do the same thing on top, square root of 3 minus 1, okay? So we're going to get the following over here. We're going to get the 4 times, so whenever we do the top one first, we can do 4 square root 3 minus 4, okay? At this point, and at the bottom, what we can do is we're going to square root of 3 times square root of 3. Okay, that's going to give me square root of 9. Okay, under square root of 3 minus 1 is going to give me minus square root of 3. 1 times square root of 3 is positive square root of 3. And I can do 1 times minus 1 is going to give me minus 1. So example, in this scenario over here, what I have is the following, okay? I'm going to, these two cancel each other out, the opposites. And then I have 3 take away 1. 3 take away 1 gives me 2, because that becomes a 3. And 3 take away 1 is 2. And then I got 4 square root 3 minus 4. Now, sorry, minus 4. Okay, now when I do 4 divide, so I can divide 2, I can do 4 divided by 2, I can do minus 4 divided by 2. Okay, so I'm going to do that. Okay, so I'm going to do that, and I'm going to get final answer is 2 square root 3 minus 2. Okay, and that's my final answer for this particular question. Okay, last question over here for simplification of surds. We're going to do the following. Okay, we're going to multiply by a positive version of the same thing, square root of 5 plus 2, and whatever is at the bottom, it is the same thing on the top. Okay, square root of 5 plus 2. Okay, so we're going to expand the brackets. Okay, so we're going to 5 times 5 is going to give me 5. Okay, I'm gonna sort of take a shortcut. Okay, I'm not gonna do too much detail. Square root of 5 times 2 is gonna give me plus 2 square root 5. Okay, and then when I do the same thing, minus 2 square root 5 is gonna give minus 2 square root 5. Okay, when I do minus 2 times plus 2 gives me minus 4. Okay, so these two cancel each other out. 5 minus 4 gives me 1. Okay, so literally the answer at the bottom is 1. Okay, now over here, let's do this one over here. Square root of 5 times square root of 5, that gives me 5. Square root of 5 times 2, that gives me 2 plus 2 square root of 5. Okay, 1 times square root of 5 gives me plus square root of 5, and 1 times 2 is going to give me 2. Okay, now what I can do, because anything divided by 1 is the same. Okay, so I'm going to leave it as that. So I'm going to add like terms. 2 and 5 goes together, that gives us 7. Plus 2 square root 5 and square root 5 gives me 3 square root 5. And that's our answer. Okay, this is the hardest it gets when it comes to surds. Okay, yeah, we can just do excellent. We can do that as well. Okay. All right. Okay. Are there any questions about this, guys? Any questions? Everyone's happy? Okay. If you're happy to move on, put your hand up. If you don't have any questions, okay. So the last topic we're gonna go through is not the last topic before we have a break. Is another important topic. Okay. All right, so let's go through so these are important topics. I'm not saying the rest aren't important topics, but topic like indices, surds, standard forms, and also when it comes to ratios. These are 4 main fundamental topics that you have to just know. Okay, so we're going to talk about standard form. Once we've done standard form, we're going to have a 10-minute break, and then we're going to come back here for the next part of the revision session. I know the revision session, you haven't done much, but it's more like you watching and seeing whether you understand it. If there's something you don't understand, you need to really go back and revise those things quickly. Okay, I'm trying my best to go through as much as I can. Also, I've had a full day, so I'm a bit tired as well. So forgive me if I'm going a bit slow. Okay. And if I go too fast, then I'm gonna upload this recording onto YouTube so you can watch it. Okay. So over here, standard form is any number that is between 1 to 9.9 recurring. It can also be negative. And this number has to only be a whole number, but it has to be negative. Okay. So this is really important. Okay. Standard form is any numbers between 1 to 9.9 recurring. It cannot be a decimal. Okay. So standard form over here will be a 5.7. Okay, so 5.7, if I want to take the decimal back, is going to be 1, 2, 3, 4. Okay, so it's going to be times 10 to the power of 4. That's very easy. Okay, so we need to understand how to convert things into standard form. This is including foundation. Okay? So guys, I'm stop the event. Sorry guys, that was the adhan. Just give me 1 second. Okay, let's go back to it. Okay, so it's a good reminder. So we have a break when we should do Maghrib, okay, whilst we're at it. Okay, so let's go back to this one. So this one was 7.5. So we got 1, 2, 3, 4 times 10 to the power of 4. Next one over here is we got the standard form. The standard number is going to be 2.8. Okay, so if I have a decimal over here, it has to go 1, 2, 3, 4, 5. And because it's going to the right, you're making it smaller, is times 10 to the power of minus 5. Okay, you're making a number bigger, sorry. is 2.8. So you make it bigger, so it's going to be a minus because you're making you made from a smaller to a bigger number, okay? If you make small to a bigger number, use a positive. All right, so that's converting standard form. Converting numbers from standard form, okay? So if I have 7, 3, 1, the decimal is jumping 5 to the right, okay? So it's jumping over here, 1, 2, 3, 4, 5. Any gaps I have, I just fill them in with zeros, and that's going to be 730,000, okay? 31,000, sorry. Next one over here, again, I write the 8 and 7, and is jumping to become a smaller number, okay? So it's going to jump to the left, okay? So I'm gonna expect a decimal. It's going to jump 1, 2, and 3. That's where the decimal is. I'm going to add the remaining spaces with zeros. That's going to be 0.0087. Okay, next question, multiplying standard form. Okay, so when we multiply standard form, we're going to multiply the two numbers over here, and that's going to give us 6, and we're going to multiply the indices separately. Okay, so this two indices are 10 to the power of 7 plus 4. Okay, so when we do that, we're going to get 6 times 10 to the power of 11. Okay, that's what we have. So that's the answer for the standard form. Okay, next question, we're going to divide standard form. Okay, so over here, first we're going to divide the 2. Okay, so we know that in this scenario over here, when we divide 2 divided by 8 is actually like, so if I do this, 2 divided by 8, okay, I'm going to get 2 over 8, okay? If I write in decimal, it's going to be 1 over 4, and 1 over 4 is the same as 0.25. Now, this is where it gets a bit complicated, okay? Not too complicated, a bit complicated. So I can just make 2 over 8 is the same as 0.25, okay? Once I got 0.25, I can do the remainder, okay? So when I divide indices, I do 10 to the power of 6 divided by 10 to the power minus 4. Okay, remember, this is where indices plays a role. Okay, so I'm going to have times 10 to the power of 6 minus 4. So the division acts as a minus when it comes to indices, and we have a minus 4 over there. Now I'm going to add the 2 because a minus and minus gives us a plus. So we're going to have 0.25 times 10 to the power of 6 to the power of minus minus, it becomes a plus 4. Okay, and that's going to give us 0.25 times 10 to the power of 10. And so once I have that, I can literally now turn it to standard form, because it's still not standard form. Standard form is a number between 1 and 9.9 recurring. So I need to move the decimal one here. Okay, I need to make it bigger. Okay, if I make it bigger, I'm going to have 2.5 times 10 to the power of minus 1 times 10 to the power of 10. Okay, now minus 1 and 10 gives us a 9. So the final answer would be 2.5 times 10 to the power of 9. Okay, and that's the final answer. That's the standard form doing these two. Now, adding standard form is the hardest. Okay, and there's two ways of doing this. One is you can really turn this into a bigger number. Okay, so you can first you can take one off. So you can call this 50 times 10 to the power of 6. And then you can add the 4 times 10 to the power of 6. So you can first turn the index to be the same. Once you turn the powers to be the same, okay, if you time, could you explain non-calculated geometry? Could you think of what that won't come up? Think that won't come up. At the end, if you have time, could you explain non-calculator geometry? Okay, I'll do that. Okay, I'm coming to that anyway. That's part of this session. Okay, so what we're going to do is we're going to add the two numbers. So we've got 54, and we don't really add these two up. So we got 10 to the power of 6, and then we turn it into a standard form. We have to take a decimal off. Okay, so we can leave this as 5.4 times 10 to the power of 1 times 10 to the power of 6. And we add those two up. So we're going to 5.4 times 10 to the power of 7. And that's the final answer for your question. All right, guys, we're gonna have a 10-minute break. Do not leave to go anywhere. You can have a 10-minute break, do your Asr, sorry, do your Maghrib, and come back at 6 past 9. Okay, 6 past 9. We're gonna finish all the way to 10, as much as we can cover, and then we stop there. Okay, 10-minute break. I'm gonna put timer on so you can see for yourself. All right, 10-minute break. Okay, I'm just gonna put myself on mute and turn the camera off. All right, guys, we've got nearly 2 more minutes left for the break. Then we're going to be carrying on with our lesson. Okay, so I'm just looking through what else we're going to go through. You guys, we got 1 more minute left, and then we're going to start. Yes, we are going to go through some tangent to circles, equation of a tangent to circle. We are going to go through some ratio, level 9. We are going to go through some density. Um, yeah, we're going to go through some other things as well. But generally, it's the main topics that are actually coming up. We're focusing mainly on the sort of level 8, level 7 topics maximum. The level 9 topics, the proving, we're not doing that now. That's answering your question. Okay. Okay, so next topic, we're going to talk about expansion of brackets. Okay, let me just close this up. And the quicker I'm going to go through this, the quicker I'm going to stop the session, okay? So then you can revise on your own, whatever you need to revise, okay? So example, expanding 3 brackets, we should know how to do that, okay? So x times x is going to give us x squared. X times minus 2 is going to give us minus 2x. Minus 5 times x is going to give us minus 5x. And minus 5 times 2 is going to give me plus 10, okay? And we have another bracket over here, okay, minus 1, okay? So at this point, we're going to have x squared minus 7x plus 10. Okay, so now we're going to expand this, okay? So x squared times x is going to give me x cubed. X squared times minus 1 is going to give minus x squared. Minus x times x is going to give me minus 7x squared. Minus 7x times minus 1 is going to give me positive 7x. And then we have 10 times x is going to give positive 10x. And 10 times minus 1 is going to give minus 10. So then we have to just collect same terms, okay? So these two go together. So we're going to have x to the power of 3 minus 8x squared. These two go together. We're going to have plus 17x minus 10. And that is your answer, okay? That's your answer for your question. All right, are there any questions in regards to this, guys? Is anyone confused? Okay, let's go to the next question over here. Okay, so we're going to talk about algebraic fractions, okay? So algebraic fractions are quite a long topic. I've just put in these two type of questions. It doesn't include all the type of questions that can come with algebraic fractions. One of the algebraic fraction questions actually is sometimes equal to 1. Okay, those are the ones that you need to look up yourself. But I'm just going to go through these. Okay, so when we simplify algebraic fractions with two numbers, we should be able to factorize quadratics. Okay, two numbers to multiply to give me 9, add to give me 6. And those two numbers are x plus 3 and x plus 3. Okay. At the bottom over here, two numbers to multiply to give me minus 15, add to give me minus 2. Okay. If I don't know those two numbers, what I can do is I can look at the factors of 15. Okay. So I can go down here and I can do, for example, now minus 15 times 1. I could do minus 5 times 3. I can do positive 5 times minus 3. I can do positive 15 times minus 1. Okay, whichever add to give me minus 2 is the correct answer. So that gives me minus 2. So that will be these will be the two correct. Okay, so the minus x minus 5 and x plus 3. Okay, once I got two brackets, I can then cancel them out. I can cancel these out. I'm going left with x plus 3 over x minus 5. And that's the answer for them. Okay, next question over here is these algebraic fractions. So what we have to do in order to solve this, we have to cross multiply them. And we're going to multiply them together like this. Okay, so we're going to have the following: 2 brackets 9x plus 1 close bracket minus 5 brackets x plus 2 close brackets, and I'm going to multiply them to each other, so I'm going to have 10. Okay, so now I need to expand them individually. That's going to be 2 times 9x is 18x, 2 times 1 is 2, minus 5 times x is minus 5x, minus 5 times plus 2 is minus 10, and all of this is over 10. Okay, so we're gonna add like terms. Okay, so 18x minus 5x is going to give us 13x, and 2 minus 10 is going to give me minus 8 over 10. Okay, so we can't simplify this further. We leave it as it is, and that's what it is. For example, now if I have a question where it says it's equal to 1 and you have to solve it, what I have to do is I have to equal this whole thing to 1 and then I have to solve it. Okay, so I'm gonna multiply both sides by 10. Okay, so I'm doing a different question. I'm not doing the same question. I'm equaling to 1. Yeah, so I'm left with 13x minus 8 equals to 10. I do plus 8 on this side, plus 8 on that side. That's going to give me 13x equals to 18. And then I can divide the side by 13. I can divide the side by 13. And x is equal to 18 over 13. That's if it was equal to a number. Okay. Right. Are there any questions about algebraic fractions? Okay. All right. Next topic. Yeah, that's correct. Yes, Selma, you are. Okay. Right. Okay. Next topic. Here. Okay. Linear inequality. Okay. So we have represent x equals to x is smaller than 2. So the crocodile mouth always goes for the bigger target. Okay. Remember, the crocodile will always go for the bigger target. So example now, a 2 will always be bigger than 1. Okay, for example. Okay, when I say this, for example, if I say 2 is this, that means 2 is bigger or equal to x. Okay, so now if I have this question over here, represent the inequality, x is bigger than 2, that means I have to draw a hollow circle on 2, and then I have to say that x is going to be bigger than 2. Okay, that's a hollow circle. All right, next question says solve the inequality. Solve this inequality. Now, how to solve it? I need to make x the subject. Okay, so what I do is I'm going to do positive 1 on this side, positive 1 on that side. Cancel out. So I'm left with 2x is equal to, is smaller than 10. Okay. So then I'm going to divide this side by 2. I'm going to divide this side by 2. And I'm going to be left with x is smaller than 5. That's the answering the question. Okay. Next example over here, we're going to see over here, write out the inequality shown in the number above. Okay, so this a hollow circle. If this was a full circle, if this was a full filled in circle, so let me get the correct pen color. If this was a filled in circle like this, okay, that would actually mean that x, okay, x is bigger or equal to -2. Okay, that's what it would mean. Okay, right. So I'm just doing that for the sake of you understanding it. Okay, so now how can we form an equation? So example now it says Lee is Y years old, Toby is 10 years younger than Lee. Okay, so if Lee is Y, Toby is 8 years younger than Lee, so Y minus 8. The sum of the age is 8, is less than 41. Okay, so it's less than 41. Okay, so Lee is Y years old, Toby is 8 years younger than Lee, and the sum of the age is smaller than 41. As you can see, as I'm going through the question, I'm actually writing notes down. Okay, write down in terms of Y inequality shown in the information. Okay, so I can write this quite simple. So I can write Y Lee plus Toby, which is this one, Y minus 8, is smaller than 41, less than 41. And that's really my answer if I want to say that, okay? If x was equal to 2, it would just be a straight line. It can't be, an inequality. It's not an equality. When I say x is equal to 2, that's not an equality. That's not inequality. That'll be equality, okay? So when I say x is equal to 2, that's an equality. Equality. So it's not the same topic because equal to 2, yeah? So that doesn't apply to her, okay? So it says, work out the oldest age Lee can be, okay? So Lee is Y. So give your answer as a whole number of years. Okay, so if I work this out, I can do Y plus Y minus 8 is smaller than 41, okay? So I'm going to do 2y. If I do positive 8 on this side, I'm going to be left with 49, okay? I do divided by 2 on this side, divided by 2 on this side, okay? That cancels out. Y is 24, it's smaller than 24.5. Okay, so Y has to be smaller than 24.5. That means work out the oldest age Lee can be. So Lee can be 24. Okay, 24 years old. Okay. It's gonna be on YouTube. I'm gonna put on my link on my status. It's gonna be on YouTube. So Lee, the oldest age Lee can be is 24 years old. Okay. Right. The next question, it says over here. Okay, so this is another inequality type of question over here. So we had to solve for x. So what we're going to do is we're going to treat them as two different inequality questions over here. So we're going to have x is smaller than 2 brackets x minus 1. Okay, that's one of the sides. And then over here, we're going to treat this as a separate question. We're going to have 2x minus 1 is smaller or equal to 7. Okay, so we're going to solve them separately, then we're going to bring them together. Okay, so over here, we're going to expand the brackets. X is smaller than 2x minus 2. Okay, over here is 2x minus 2 is smaller or equal to 7. We solve for x. Okay, so over here, we're going to get the following. We can leave it as that. Okay, so we do minus x, okay, and we could do plus 2 and plus 2. So we're left with 2 is smaller than x, okay, at this point. Over here, we're going to do the same thing. Plus 2, plus 2. Cancels out. We're left with 2x is smaller or equal to 9. We can divide this by 2, divide this by 2. X is smaller or equal to 4.5. Okay, now, once we have these two, we can bring them back together, okay? So we can say 2 is smaller than x, and x is smaller or equal to 4.5. Okay, that's the answer for this one. All right, are there any questions about this? Okay, all right, everyone's happy? Okay, so let's move on to the next one. Okay, so forming an equation, okay? We need to know how to form an equation at this point as well, okay? Let me just check what the time is. All right, so it's 9:20 still, okay? So Sarah is X years old, Thomas is, so Sarah is X, let's write this down. Thomas is 3 years older than Sarah, so Thomas is X plus 3. David is twice as old as Sarah, so David is 2 times X. Total of the age is 51. Write an expression for Thomas' age in terms of X. So Thomas is going to be X plus 3. We already wrote that down, so that's done. Okay, next question is right expression of David's age in terms of x. So David is 2 times x, which is the same as 2x. Let's form an equation for x and solve out Sarah's age. So we can write x plus 3 plus x plus 2x equals to 51. Okay, so we try to solve the x. Okay, we add all the x's up. This is x, x, and x. So we got 4x's plus 3 equals to 51. Okay, we do minus 3 on this side, minus 3 on this side, cancels out. So we're left with 4x equals to 48. We divide the side by 4, divide the side by 4. That's going to give us Sarah's age is equal to 12. So she's 12 years old. Okay, that's forming an equation. All right, next topic over here is this one, okay? Factorizing and solving quadratics and plotting quadratics. This is a long topic, but I'm just going to summarize it as much as I can. Okay, so in order to factorize a quadratic, we have to be able to multiply by two numbers that multiply to give us 15, add to give us 8. Okay, so if we don't know those numbers, a lot of people struggle with this. We can look at the factors of 15. Okay, what are the two numbers that multiply to give us 15? 15, 1, 5, 3, minus 5, minus 3, minus 15, minus 1. Okay, and we can see what number adds to give us 8 is this one over here. So we know it's these two. Okay, so we can write x plus 5 and x plus 3. Okay, and every quadratic is equal to 0. Now we learn how to solve it, factorize it. How do we solve a quadratic? Okay, we can solve it by equal each bracket to 0. Okay, so we equal this bracket to 0, equal this bracket to 0. So what we have over here is we have x plus 5 equal to 0. So one of the solutions for x is minus 5 minus 5, and that cancels out. We're left with x minus 5. Okay, that's one of them. Okay, over here, same thing. Okay, with x plus 3 equals 0. The minus 3 over here, minus 3 over here. X equals to minus 3. Okay, that's the two solutions. We learn how to solve quadratics. Okay, now what does solutions mean? When we draw a quadratic, we can also talk about this. Okay, so when we're drawing quadratic, we can also talk about this. So at this point, we can say that the graph is going to cross the x-axis at minus 3. Okay, at minus 3 and at minus 5. And we have the equation, which is ax squared plus bx plus c, where c is the y-intercept, okay? So the graph intercepts the y-axis at 15, which is over here. Okay, so it's going to go something like this. Over here like this, and up like this. This is how a graph is going to look like, okay? And because this is a positive, it's going to be a smiley face, okay? is positive, okay? If it was negative, it would be in a negative phase. That's how you determine or draw these quadratics. Now, how can I look for the minimum point? The minimum point is this, and this is what we're going to talk about, completing the square. Okay, so when we complete the square, completing the square. Completing the square allows us to find the minimum or maximum point. So we look for max or minimum point, okay? Okay, so at this point over here, we can use the equation y equals to x plus b over 2 squared minus b over 2 squared plus c. That's my equation over here. So if you have ax squared plus bx plus c, my b is going to be 8, my c is going to be 15. Okay, so I'm going to substitute the values over here. Y equals to x plus 8 over 2, which is 4 squared, minus 8 over 2, which is 4 squared, which is 16, plus 15. Okay, plus 15. So when I do this, I'm going to get y equals to x plus 4 squared, minus 16 plus 15 is minus 1. Minus 1. So your x value is going to be opposite of what's in the bracket, which is x minus 4, and your y value is going to be whatever's outside, y equals to minus 1, okay? So we can say that this point over here, the minimum point over here, is going to be minus 4 and minus 1. That's how you complete the square. All right, next topic. Okay, for example now, when we have a topic like this, for example, this is quite hard as well, okay? So example now, let's use 5 because I don't think that's going to work if it's 6. Okay, so if I do, I can use the AC method over here, okay, to factorize this, okay? So two numbers that multiply to give me AC, add to give me B. So we have AX squared plus BX plus C at this instant. So AC means A times C. 6 times 5 is 30, okay? 30. And B is 13. Two numbers that multiply to give me 30, add to give me 13. That is 10 and 3. Okay. Now if I want to factorize it, I'm going to divide each number by this over here. So it's going to be divided by 6x divided by 6x. Now, can I simplify further? Yes, I can. Treat it as a fraction, so I can simplify this fraction as much as possible. Divide top number by 3, divide the bottom number by 3. Now I'm left with 1 over 2x. So one of my brackets are going to be 2x plus 1. Okay, the other brackets I can divide both sides by 2, divided by 2, divided by 2. That becomes 5 over 3x. So my other bracket is going to be 3x plus 5. Okay, so now if I put them together, I'm going to be left with 3x plus 5 and 2x plus 1. Okay, once I've done that, I'm going to then, if I want to solve it, okay, I'm going to make them equal to 0. Make them equal to 0, make them equal to 0. Okay, so I got 3x plus 5 equal to 0. Okay, and over here I'm going to go 2x plus 1 equal to 0. Okay, I'm going to make x the subject. Okay, so I'm going to do minus 5 over here. That cancels out. I'm left with 3x equals to minus 5. Okay, over here I'm going to do minus 1. Okay, I'm going to do 2x equals to minus 1. We have divided by 2, divided by 2, divided by 3, divided by 3, and one of the solutions for x is equal to minus 5 over 3, and the over here is going to be x is equal to minus 1 over 2. When it comes to graphically, what that means is if you have a graph, yeah, you should be able to draw it up. Okay, where these 2 points is where the curve crosses the x-axis. Okay, all right, that's this topic. Okay, let's move on to the next topic. Okay, so this is a bit of a year 9 topic. Okay, so we have line A is a tangent to a circle, x squared plus y squared equals 40 at point A. Okay, so now before we do this question, we need to know how this works. We need to first know what is equation of a circle is. Equation of a circle is this, okay? We have x squared plus y squared equals r squared, which means whatever number that is, the radius is going to be equal to the square root of that, okay? So in this case, the radius is equal to square root of 40. But we're not working out the radius, okay? And when we have points like this, x squared and y squared, that means we are at the origin. So the origin of the circle is going to be the center point, and the radius is square root of 40. If the origin was, for example, x minus 1 squared plus, let's say, y minus 2 squared, that means the origin, okay, the center of the circle would have been 1 and 2, okay? It would have been this, okay, the coordinates 1 and 2, but it's not like that, okay? We're talking about the origin is 0, 0, okay? Just make dua that you don't get the question where the origin is any different from 0, 0 if you get this question. If you do, you have to understand this point, okay? Right, so if we were to draw this out, we have a circle, we have a graph over here. In your circle, I can't draw a perfect circle, but I'll try my best. This is your circle, okay? Now the question says point A, so we're drawing the first one. A line L is a tangent to the circle, okay? We don't know which side the tangent is. We don't know if it's the left or the right or the bottom. It says the point A is 2 and 4. So it's 2 and 6. 2 and 6 is somewhere here, okay? So the tangent is at point A. Point A is 2 and 6. So we can draw a line over here. That's the tangent, okay? That's 2 and 6. Okay, now the question says the tangent crosses the x-axis at P. So it crosses the x-axis at P. We should understand what that means, okay? And so the question says, number one, calculate the tangent where the tangent crosses the x-axis. So when at P, the coordinates, we don't know what the x value is, but we do know what the y value is, because the y value, when something crosses the x-axis, the y value has to be 0. So we know the y value is 0. Okay. Now this is a hard question, okay, level 9 question, okay, because we first need to find out the gradient of the line, okay, tangent equation of the gradient of the line. Usually the question says find the equation of a tangent to the circle. Okay, so what we're going to do is we're going to work out the normal. Okay, the normal is the perpendicular line. Okay, so over here, the normal is literally the line that goes straight through this over here. Okay, is 90 degrees to this line over here. Okay, so if I look over here, the difference in y is going to be 6, and the difference in x is going to be 2. So the difference in x is equal to, the difference in y is equal to 6. Now to find out the gradient of a normal, so the m, that means m is equal to difference in y divided by difference in x. So I can say that the gradient of the normal, the blue line, is going to be 6 over 2, which is equal to 3. Okay, so the gradient of the m is 3. Now, if I want to find the gradient of the red line, okay, if I want to find the gradient of the red line, I have to look at the negative reciprocal, okay? So if I look at the perpendicular gradient, okay, if we look at, so if I want to look at the perpendicular gradient, so perpendicular gradient is, the equation is -1 over m, okay, at this point. All right, so we're going to have -1 over m, and your m is going to be 3. So we're going to have the perpendicular gradient is equal to -1 over 3. So here is -1 over 3. That's the gradient of this red line over here. Now, once we find the gradient of the red line, we can find the equation of the red line, okay? So we can put everything into y equals mx plus c, y equals mx plus c to find out. So we got the m, which is minus 1 over 3, minus 1 over 3. We got the x because we got a coordinate on the line, which is 2, and the y is 6. But we don't know what c is. So we're going to find out what c is. Once we find out what c is, we got the equation of the line, okay? So let's do this, okay? So at this point, we have this one over here, okay? So we're going to have 6 equals to minus 1 over 3 times 2 plus c, okay? So now, once we have that, we're going to have 6 equals to minus 2 over 3 plus c, okay? We're going to move this over to the other side. We're going to have 6 plus 2 over 3 equals c. And so we can say c, if I want to turn this into fraction, 6 over 1 plus 2 over 3 equals c. If I multiply this by 3, I multiply this by 3, I got 18 over 3 plus 2 over 3 equals c. And the final answer for c is 20 over 3 equals c. Okay, so now I got the equation of the line. The equation of the line would be the following. It would be y equals to minus 1 over 3 x plus 20 over 3. Okay, now I haven't even done the question. Okay, that's the sad part. Okay, okay, that's why it's a grade level 9 question. Okay, where calculate where tangent crosses the x-axis. So we need to find out what's the x coordinate. What's this number that goes here? That's what we're trying to find out. So now I can substitute this is my x value and this is my y value. I can substitute my y value into this equation to find out what x is going to be. Okay, so let's do that. So I can put y where I can put 0 where y is. So it's going to be 0 equals to minus 1 over 3 x plus 20 over 3. Now, to get rid of the fraction, I can multiply everything by 3. Okay, that's going to cancel out. That's going to cancel out. 0 times 3 is 0. So we leave it at this. Okay, so it's going to be 0 equals to minus x plus 20. So if I want to find what x is, I move to the other side, plus x, and I'm left with x equals to 20. Okay, now the coordinate for P is 20. We finally answered the question. It's literally a 5-mark answer, okay? It's quite complicated. This is a level 9 question, okay? Now, once I got once I got understanding that this is 20, the next question says calculate the area of OAP. So if this is O and this is A and this is P, they want me to calculate literally the area over here. Okay, they want me to calculate the area of this triangle over here. Okay, which is long. Okay, it's not that difficult. Okay, so now remember the equation of a triangle. Let me use a different color pen. Is half times base times height. So if I got the height, which is 6, I got it here, and I got the base, which is 20. So all I have to do is that's height, that's base, I have to times by each other divided by 2. Okay, so I do half times base times height. Okay, so half times base, which is 20, times height, which is 6. Okay, I multiply the 2, or I can cancel this out. I can get 10 times 6, that's going to be 60. So the area is 60. There's no units for it. If it was centimeters, it would be centimeters squared. So the area is 60 of the OAP. Okay, these are very difficult questions. Does anyone have any questions about this? If you don't understand this, you can always watch the recording back. Are there any questions particular? If you don't understand it, then there's nothing, you have to just rewatch it, okay? All right, so let's go to the next typical question, okay? So we're looking at the speed and time graph, okay? Speed and time graph is an underestimated question because a lot of people neglect graph questions, okay? because they think, oh, let me focus on algebra, let me focus on all the hard questions, let me focus on trigonometry, but you completely neglect graph questions. And even if you have an idea of the graph questions, you will completely, it will take you off by surprise, okay? So the speed time graph, the area under the graph is actually the distance, okay? So if I want to work out the air, it says calculate the distance between the houses. So the graph shows the speed of bikes between the two houses, okay? So you have the one house to another house, and the distance under the graph sort of allows you to calculate the overall distance between two houses, okay? So either we can break it down into two, or either we can use the trapezium rule, okay? So remember, we can label the sides A, so this is A, and we can label this side B, this is B, okay? And we can times it by, this is the height, which is 14. So remember the equation for trapezium rule is A plus B times height divided by 2. Okay, I'm sure that's the equation, if I'm not wrong. Okay. Okay, so we add the two. No, sorry. No, this is correct. Sorry. Let me do that again. A times B divided by 2 times height. Yes, that's the one. Okay, same thing. Okay, so we add the two. So A is the difference between these two is going to be 13. Okay, B is 60. So if I write over here, it's going to be 13 plus 60 divided by 2 times the height, which is 14. Okay, so over here, I'm going to have 73. Okay, 73 at this point, and then I'm going to times it by, so 73 divided by 2. Okay, so I know that how many 2 goes into 7? We can say 3. Okay, what's the remainder? 1. How many 2 goes into 13? That is 6. Okay, decimal there. What's the remainder? 1 goes there. How many 2 goes into 10 is 5. Okay, so we have 36.5 is the answer for this. Okay, now because a non-calculator question, they will give you something like this because they want you to multiply decimals. Okay, so they're going to say, okay, 36.5 times 14. Okay, now what we got to do is we're going to take out the decimal out, and we could do 365 times 14. Okay, and we can multiply them, and then we can add back the decimal. Okay, so if we do 4 times 5 is going to be 20. We do 4 times 6 is 24, plus 2 is 26. 6, 2. 4 times 3 is 12, plus 2 is 14. Okay, this is the time my brain starts going blank, okay? After doing maths all day and doing this on top. All right, so let's do the next one. 1 times 5 is 5. 1 times 6 is 6. 1 times 3 is 3. And we add the 2. Hopefully this is correct. 0, 11, 10, 11, 5. Okay, and now because we're taking a decimal away, we can cross this out. So it's going to be 511 meters is the distance between the two houses. Okay, next question. It says work out an estimate for the distance traveled over 60 over 6 seconds. Okay, this is so this time we have a speed time graph that that is it's a curved graph. Okay, using 3 equal strips. 3 equal strips means 6 divided by 3. We have to, sorry, 3 is going to give us 2. So every 2 seconds we have to make it into a sort of trapezium. Okay, so that's first one, and that is 1, 2, 3. Okay, so let's make it over here, this over here. And so we got different, so we got triangle over here. Okay, that's one. And then we got another trapezium over here, and then we got another trapezium over here. Okay, so we got the whole area consists of 3 trapeziums. Okay, Work out the estimate for the distance. So the distance is the area under the graph, okay? So we have to literally work out, let me just check what the time is. Okay, 43. Let me see how many topics we've got left. Sorry, guys, just give me 1 second. Okay, we've still got quite a few topics left, okay? Okay, let me rush through this as much as I can, okay? Let me try to rush through as much as I can. So we have to work out the area between each of these, okay? So area over here, we can say the difference is, for example, now we have 12. So this is 12, and we can say this is 11. So the first trapezium will be 12 plus 11 over 2 times the height. The height is going to be 2, okay? So we can cross these two out and we can just add these two on. It's going to be 23, okay? Next one over here, we have the following, okay? So we have from here to here, okay? So we have, for example, now this is 11 plus, that's going to be approximately 9. 11 plus 9 divided by 2 times 2. That's the height, okay? These crosses out and I'm left with 20, okay? And the last one over here is area of a triangle, okay? So that's base times height. The base is, we can say 9 times 2 divided by 2, cancels out, that's 9. So we have 23 plus 20 plus 9. Okay, that's going to give me 43 plus 9, and that's going to give me 52. Okay, 52, because we're talking about meters, we're talking about meters over here. So the distance is 52 meters, okay? Where am I getting 11 from? 11 is the distance over here. Can you see that? That's the 11, okay? The distance over here is approximately, sorry, the distance over here is approximately 9. That's where I get 9 from, okay? So I'm looking at it from a different perspective, okay? So I get 52 over here. Okay, that's the distance under the graph. Now, is your answer an overestimate or underestimate? It's an underestimate because I haven't taken these parts into consideration. So it's an underestimate. Underestimate. Okay, guys, let's move on. Okay, there's a few topics we may not be able to do, but let's quickly go through them as much as possible. Okay, so over here, the question says the gradient of parallel and perpendicular lines. Okay, so we're going to look at lines that are perpendicular and parallel. Parallel is when the gradient are the same. Okay, so if we make y the subject, we should have the answer over here, y equals to minus x plus 6. We should make this into y equals, so it's positive 2x, positive 2x. This cancels out. So we left it y equals 2x plus 7. And over here, we have minus 2x minus 2x. So we can work out y equals to minus 2x plus 3. Now it says which two lines are parallel? Parallel is where the graph is the same. So this has 2x and this has 2x. So I can say line A and D. A and D are parallel, okay? The next question says is, which two lines are perpendicular? Now, perpendicular, if I work out, for example, now, if I do a reciprocal of a gradient, okay? If I do a reciprocal of a gradient, that's going to give me a perpendicular gradient. So, example, now, if I do a reciprocal of 2, that's a minus a half, okay? And I don't have a minus a half anywhere here. So if so I've done this, and I've done this in a way, okay? So if I do a minus 1 over a half, sorry, let me just use my, okay, minus a half, that's going to flip over and that's going to be minus 2. So I can say that this is perpendicular to this line, okay? So B and E. B and E, not C. B and E. These two are perpendicular lines. Okay, let's go to the next topic. Percentage of an amount. Okay. We've done that already. Okay, so let's move on to the next one. Ratios. Okay. Okay, let me see how much time we got left. Okay, let's try to finish this off. Okay, ratios of it. So example, if I talk about ratios, it says the ratio of muffins to cupcakes in a cake sale is 3 to 1. Okay, there are 20 cakes in total. How many muffins are there? So muffins to cupcakes. Okay, so M. So I can write M and C over here. So the total, so 20 cakes is equal to 4 parts. Okay, so 1 part, I need to just divide it by 4. Okay, divide it by 4, divide this by 4, and that's going to give me 5 cakes. Okay, and we're looking at muffins. Okay, muffins are 3 parts. Okay, so I need to look at 3 parts. So I multiply this by 3, and I multiply this by 3, and that's 15 cakes or muffins. Okay, next question. The ratio of red to blue is 3 and 5. Red to blue is 3 and 5. The ratio of blue to green is 6 and 7. What's the ratio of red to green? Okay, so we can write some red, blue, and green. Okay, so red to blue is 3 and 5, and blue to green is going to be 6 to 7. Okay, so I can multiply these two, and I'm going to get 30 over here. How do I get from 6 to 30? I times it by 5. I times this by 5. So that's 35. How do I get from 5 to 30? I times it by 6. I can times this by 6 as well. I'm going to get 18. So the ratio from red to green would be 18 ratio 35. Okay, next question. Javi and Carmen share some money in the ratio of 5 and 6. Each are given £4 more. How the ratio of the money is now 6 and 7. How much money did they initially have? Okay, so what we're going to do in this scenario over here, we say that 5 and 6 are a scale factor. Okay, so we can write Javier and Carmen had 5x and 6x. Okay, we don't know the amount. Okay, well, we know it's a scale factor of x to 5, x times 6. Okay, they are given each £4 more. So after the difference, after £5, after giving £4 more, ratio 6x plus 4, we know that the ratio now is equal to 6 and 7. Now, so 5x plus 4 is 6 parts, 6x plus 4 is 7 parts. So to find out what 1 part is, I can do 5x plus 4 divided by 6 gives me 1 part. Okay, and I can say 6x plus 4 gives me 7 parts. That's 1 part as well. Divided by 7 gives me 1 part. So if that's the case, I can make these two equal to each other, okay? So I can say 5x plus 4 over 6 equals to 6x plus 4 over 7. I cross multiply them, and I should get 35x plus 28 equals to 36x plus 24. Okay, now if I want to make x a subject, I do minus 35x, I do minus 35x. I cancel this out, and I'll do the same thing on this side. Minus 24, minus 24. I cancel this out. So 4 is equal to x. So the scale factor is 4. So when I add 4 back in here, 5 times 4, and I do ratio 6 times 4, I'm going to get that Javert had 20 and Carmen had £24. Okay, and that's the answer. All right, next question. We nearly finished, guys. Okay, polygons. Okay, so we talk about polygons over here. Let's leave the polygons for time being. Okay, area, sectors. Okay, this is important. Okay, so exact trigonometric values. Okay, it's very important that you memorize these values. Okay, so I would recommend you memorize these values. They're gonna come up. Trust me, they're gonna come up. You're going to have to tell the examiner what the value is of sin 0 or cos 60 or something along the lines. You have to memorize them. Okay, for example, now if I memorize these triangles, I should know what sin 0 is, okay? So sin 0, okay, in this scenario over here, I can say that sin 0 is at this point over here. So sin 0 is going to give me 0, okay, at this point. It's going to give me 0, okay? As for cos 60, if I use cos 60 over here, I'm looking at SOHCAHTOA, okay? So SOHCAH and TOA, okay? So CAH is adjacent over hypotenuse. So if this is 60, adjacent and hypotenuse is 2, and adjacent is going to be 1, okay? So if I do cos 60, the adjacent is 1 over 2. So I can say cos 60 is a half, okay? And yeah, I can sort of work that out there as well, okay? Next one is sin 30. So if I use sin 30, I can say if I use 30, 30 is opposite over hypotenuse. So sin 30 equals to opposite, which is 1, okay, over hypotenuse, which is 2. So it's 1 over 2, which is that, okay? That's the reason why this diagram is so useful. Tan 0, okay? If I look at tan 0, okay, at the moment we don't have that, but it's actually 1, okay? We have to look at the graph of that, and so on and so forth, okay? So let's move on with the next one, okay? All right, so we got vectors. Let me see what the time is. 55 or 5 more minutes left. Okay, this is another grade 9 topic, okay? So in this scenario over here, we have a vector question. Let me just see what other topics we have. I think this is the last topic we're going to do. Then we've finished. Okay, so ABC is a triangle, okay? AB is 2A, okay? So let's write 2A. AO is 6B, okay? 6B. AP is 2 and 1, okay? So that's 2 parts out of 3, okay? And PO is 1 part out of 3, okay? All together, so I can say if I do 6 times 2 over 3, that's 12 over 3. So that's going to be 4B, and that's going to be 2B, okay? And now is the question over here. It says find the vector OB, okay? In terms of A, okay? So we know that going up is 6B. The opposite of that is going to be minus 6B, okay? So OB is equivalent to OA plus AB, okay? So we're using vectors as roads, okay? So OB is equal to minus 6B plus 2A. And we leave it there, okay? Then it says Q is a midpoint of OB and B is a midpoint of AC, okay? And the question says, show that PQC is a straight line, okay? Now so if I want to work out PCQ is a straight line, I have to work out PQ and I have to work out QC, or either P to C, okay? So I have to work to P to C, okay? And if both are a multiple of each other, they are in a straight line, okay? So P to Q is quite straightforward, okay? So if I want to go from P to O, okay, we know that go from P to O, so P to Q is P to O first and foremost. And then from P to O, I'm going to work out half O to B, okay? That's first one. And then P to C, I'm going to work out minus 4B, sorry, which is P to A. And then because it's a midpoint, I can write this as 2, this is also 2A, okay? So that's going to be A to C, okay? Plus A to C. So let's insert the numbers, okay? So PO is going to be literally this point, 2B, okay? 2B. Half OB is going to be minus 6B. So if I look at OB, I can just put this in, okay? I can just put this inside the brackets, okay? So minus 6B plus 2A. And over here, when I have PA, okay, so PA is going to be minus 4B, and then over here is going to be A to C is going to be 2A plus 2A. It's going to be 4 plus 4A, okay? So we have a multiple of 2, okay? So now let's just solve this one. So PQ can be solved into the following. We got 2B plus half times minus 6 is minus 3. So let's just get rid of the plus. So that gives minus B, and half times 2 is A. Okay, so I can literally simplify this as minus B plus A. Sorry, there's not minus A, it's plus A. Okay, and I can look at PC as well. PC is equal to minus 4B plus A. So I can see 4A, sorry. So I can see that PC is 4 times the amount what PQ is. They are a multiple of each other. You can see we've got the same notations, therefore they are in a straight line, and PC is 4 times the length of PQ. That's the answer. All right, guys, we're gonna stop here. Dot at 10 p.m. I didn't finish all the topics. There are a few more topics that you want to maybe go through, like the graph topics. But I hope you all benefited from this revision session. It was quite intense for me to go through this, yeah. So it's lastminute.com. But thank you so much for you guys to attend. And I hope you guys do really well in the exam. Just make a lot of dua. Make sure you guys are very sleeping. Make sure you have your sleep and don't overburden yourself. Yeah, you can do the best you can do is put your trust in God and Allah, and you can leave the rest. Okay, that's the best you can do. Thank you so much, guys. Take care. Hope you have a good evening. Make sure you sleep on time. Okay, take care. Slime.